let's say, greater than a tread of marching armies is the power of an idea of whose time has come. And this is very most aptly applies to the MagneGas technology. Not only its time has come, but it's been long overdue. So I would like to introduce the many different applications. Before you've heard some of the things, but go into a little more detail. Basically, we're converting problems to opportunities. As you can say, turning trash to cash. This is just some of the at a glance, treating human waste and animal waste, all sorts of hydrocarbon liquid wastes, various different hydrocarbon liquid wastes, which industries pay just to get rid of between $180 and $400 a cubic meter, and they store it. They do not get rid of it. The MagneGas reactors, the path recyclers eliminate these liquids from the planet while producing a clean, environmentally clean fuel. So we see we have no shortage of liquid wastes as our feedstock, which we're paid to treat. You take a problem and turn it into an opportunity. With heavy crude, which is 6 times more heavy crude oil than light sweet crude, which is very cheap, and there isn't very many uses for it. Now, with the half recyclers, we can take heavy crude oil, and for every barrel of heavy crude oil, mix 2 barrels of water or sewage waste, which you are paid to treat, to turn into very large volumes of MagneGas. This is some of the recyclers there's an arc, plasma arc, which reaches temperatures of 10,000 degrees Fahrenheit, very high amperage, powerful ultraviolet rays which deactivate the biological activity of the sludge. And then we get from this fluid, which is high and rich in organic fertilizer, and the production of MagneGas. These are some various different reactors. This reactor here on the trailer is in India. Various different reactors, different sizes. And the nice thing about this technology is that it's modular and you can grow as you go. Unlike the current technologies that treat sewage, in which a typical municipal treatment plant can grow upwards from $30 to $50 million, half of it spent on cement. And it requires a large area, and it produces smell throughout the entire area. The advantages to these recyclers is that there is no noise, no smells. The only thing that comes out of these reactors for the flow through is water with organic fertilizer and MagneGas. With the total recyclers, which are used for recycling hydrocarbon petrochemical wastes, the only thing that comes out is extreme heat, which you can recycle also energy through heat exchangers, and MagneGas. This is the linear recycler, which is used to treat municipal sewage. As you see in this picture, these reactors are put in series, so that because the sewage you can't stop even for one moment. So when we have to service one reactor, we bypass it while we do the service, and it continues to the other reactors. This is the total recycler, which is used to treat hydrocarbon liquid wastes. And because it produces enormous amount of heat, we can use heat exchangers also to utilize electricity to offset the cost of electricity for running the plant. And of course, as you can see, there are various uses. It is a one-on-one replacement for natural gas and other fuels. Just a little diagram of the flow from turning the waste, both animal and human, and the petrochemical wastes. The nice thing about this technology is that instead of taking the waste to the plant, because these reactors are modular and you can grow as you go, they are also mobile. This system can be taken to the place where the waste is being produced, so we avoid the cost of transporting the waste either to dump it somewhere or to take it to a facility to be treated. Also, the byproducts here, there's a number of byproducts here. Hydrogen is one of them, but it is MagneHydrogen. One of the unique things about MagneHydrogen is 7.5 times more dense than normal hydrogen. And the implications of that are that you do not require to store it in cryogenic containers, which is very expensive. And we reduce the cost of storage and transportation by about 20%. These are all the various uses that we can also, for using it for coal. We will, in the next few slides, see the implications of that. Hydrogen is a very sought-after commodity. It's a $3 trillion a year industry in the world. Currently, they use electrolysis and steam reformation in natural gas, which is a very polluting process in itself and prohibitively expensive. Therefore, it will not be a reality. And another point that I'd like to make, which Professor Santilli was the first scientist to bring to the world's attention, with all the hysteria of going to a hydrogen economy, that with regular hydrogen, when we burn it, it consumes 10 times more oxygen from the atmosphere to burn than regular gasoline. So if we went to a complete hydrogen economy, as governments have planned and are spending billions of dollars to do, or try to do, or planning to do, within a matter of years we will basically suffocate the planet because we're removing oxygen. Because when you burn conventional hydrogen, sure, the exhaust is clean, it is water vapor, but you've just robbed from the atmosphere an enormous amount of oxygen, which is not being replaced. And this is something that Professor Santini is the first to bring to the world's attention, and we hope that they listen.
Thank you.
They just need this to listen. Okay. MagneGas is a very clean fuel, 150 octane. Jet fuel is only 110. And it is, of course, renewable, non-polluting fuel, and available in unlimited quantities because we have unlimited quantities of liquid waste. This is a comparison chart of the combustion of MagneGas in comparison to natural gas and gasoline. And we have the EPA standards. As you can see, that natural gas and gasoline.
Could you use the stick, please?
Yes.
Thank you.
As you can see, we have MagneGas in comparison to natural gas and gasoline and the EPA standards. As you can see from EPA certified lab tests of the emissions, that actually there are a lot of people saying that burning natural gas is cleaner. Well, this proves opposite to that in fact natural gas is far more polluting than MagneGas. In fact, far more polluting than gasoline as far as the emissions. So this is something that people want to deny, but they want to speak for themselves. Okay, there are many applications, as you can see. Vehicles, particularly race vehicles, because it is a compressed gas, refueling only takes 7 seconds. So, as in a race, Professor Santilli is one of his hobbies. He knows that every second counts. So, this should be embraced by the race car industry, which we're hoping they'll wake up to that one day. Kyoto, because we're reducing the carbon emissions, another income stream will also be from Kyoto. Whoever is a signatory to Kyoto, that is an additional profit center for people who require and operate MagneGas recyclers, where they can also get money from Kyoto. Another advantage here is for power plants. We have a big problem with power plants in that in the off-peak, whatever you don't use, you lose. This electricity, these large power plants, you can't just turn them on and off. So this technology will enable power plants to receive an income for cleaning liquid wastes, which gives them an extra income. In addition, at night at off-peak, they can utilize the off-peak electricity and run the recyclers to produce MagneGas, which can be stored in cylinders and used at peak. So they now recuperate all the off-peak electricity that is now going to waste. This is off-the-shelf technology, which will need a slight modification to separate out the hydrogen from MagneGas. This is MagneGas, the hydrogen is 7.5 times more dense. Some minor modifications will be made to existing off-the-shelf technology called pressure swing absorption, which will separate out the hydrogen from the MagneGas, leaving us MagneCO, which can be burned similar to natural gas. It is not thrown away, and MagneHydrogen. It is a $3 trillion a year industry in the world, so we certainly don't need to convince anyone to buy it because the market exists. As you mentioned also, the Kyoto emissions trading credits, free money. Not only does it reduce the carbon dioxide output, it is also reducing 14%, even up to 20% depending on the feedstock, of oxygen into the atmosphere. This is the first fuel which is actually life-sustaining, as opposed to the fossil fuels, which many people in Israel, for example, 3,000 people a year die from air pollution. A very important application. This applies not to just also China, which burns a lot of coal. In Israel in particular, 50% of all the electricity produced in Israel is using coal, which is very, very, very polluting. Here you can see coal being burned without MagneGas and with MagneGas. Because MagneGas contains hydrogen, the flame temperature being very high, we're getting a more thorough burn. The pollution that's going up the smokestack is basically unburned carbon from the coal. So with the addition of MagneGas, approximately 1/3 MagneGas at the burn site, we more thoroughly burn the fuel. So there are two things that happen. First, we increase the efficiency from the current 30% of burn efficiency. We can get it up to about 60% burn efficiency. So we're going to increase the burn efficiency, therefore requiring far less coal, while at the same time reducing emissions between 80 and 90%. Because we're going to be doing a lot of testing to test out and see and verify and get the numbers to verify what Professor Santilli already knows to be so. What I just said is basically written down there. A lot of that energy is basically going up the smokestack, so they can recuperate this lost energy. And actually, coal, which is still a very large supply, we can now utilize it to produce green electricity. Also, because of the reduction of the emissions from the coal burning power plants, the problem with acid rain would be substantially reduced. Okay, the applications, okay, of converting into hydrogen. said, this is a very large market, which you don't need to convince customers to buy. It is used for many, many applications. These are some of the applications that are used, that hydrogen is used in many, many industrial applications, whether it's factories, for producing fertilizer. One of the largest uses of hydrogen is nitrogen fixation from the air to produce fertilizer. So now we can have a cheaper way of producing hydrogen to make fertilizer even cheaper, which will be good for the farmers, which will also reduce the cost of the produce that is produced. As you can see, these are the current methods of producing hydrogen, from natural gas, oil, coal, electrolysis. Of course, these are very, very expensive processes, and they're very polluting, actually. So we're actually producing more pollution from producing hydrogen in this old-fashioned manner. As discussed before in the last presentation, MagneGas is absolutely a superior cutting gas to oxyacetylene. It cuts 50% faster. There is no flashback, so it creates a very clean cut, no slag, so there's less work in cleaning the cutting surface. You don't need vents and masks because the exhaust is clean, especially when used in ships where you're in enclosed spaces. Using oxyacetylene is very dangerous. In fact, many workers who do work with oxyacetylene in closed environments get all sorts of deadly illnesses as a result of their occupation, breathing in the toxic exhausts of combustion of oxyacetylene. Also, in oxyacetylene, 1/3 of the fuel, the oxyacetylene in the tank does not come out, so you're paying for something that you're not even using. With MagneGas, we don't have that problem. This is a picture is worth 1,000 words. This is city sewage before, and as you can see, clear water after, with organic fertilizer. It can even be further put through off-the-shelf technologies such as ozone and reverse osmosis, where we can raise the level of the quality of the water to actually be drinking water. Thank you very much.
So is there any question about Dr. Mendel's presentation regarding MagneGas technology, its engineering application? Yes, please.
What is the physics behind MagneGas?
Okay. Okay, well, I have no problem reverting to that discussion.
So it's very well known. The difficult job is to achieve the efficiency that you heard. And that, so that what required many years. Required fundamentally new mathematics, new physics, and basically new chemistry. The philosophy beyond all this, everything you heard is the result of all the mathematics, physics, and chemistry that has been worked out. The philosophy, however, this, which I hope may be of some assistance to you for superconductivity, is that we avoided any construction, any practical work, until we had a workable theory. Until we had this, I don't know if you remember the my lecture on Genomechanics was until 1997 we achieved invariance. We started first construction in 1998, not before. The reason being because until you have a viable theory, you use a trial and error, a trial and error, a trial and error. Now, I also have to be blunt. There is no possibility whatsoever that I could use 20th century theory in their entirety. For a long series of reasons, the long series of reasons that we don't have the time, it will take you a semester to. But you ask yourself the basic question that the Texan, the Seagull was a Texan, but he's not stupid. Tell me, if I use Einstein relativity, Dr. Santilli, what are you doing? Show me how you would find resistance, electrical resistance of the arc in the air via Einstein relativity. Of course you cannot do. Or via quantum mechanics. Of course I cannot do. Since we are not in academia, we are abyssally away from academia. We are in the money market. This was investors, they want to see results. Einstein doesn't exist. Einstein interest don't exist. They want to see the real thing. So that's why we have been mandated by the industry to develop basically new sciences. It depends dramatically from liquid to liquid. But it is very, very mysterious. It's extremely mysterious. And that's basically, I want to close with so basically, I would like to invite all of you to be part of this continued effort because, ladies and gentlemen, we are living with help. We are not talking about...
We want to convert a small portion of the gas, because I'll give you an example, just some numbers. Let's start with a 100 kilowatt reactor treating city sewage. Process any quantity of sewage. And the nice thing about this technology is modular. Unlike other sewage treatment technologies, which you have to make a huge capital investment without really seeing the true results, say that they are wrong or they can do something better. He always criticizes himself, and I very much appreciate it. And my love for him is not just for his genius, but for his brutal honesty. And for flying in the face of convention. We need more people like that in our world.
I have one point to clarify, an important point. This 0-point energy, no, is truly grounded. It is the energy of petroleum, the energy of carbon combustion, which is because the central source of energy in our reactor is not the arc. The arc is very little. I told you that the resistance collapses to the fraction of an ohm. It's just the spark. The primary source of energy is the carbon, the combustion of the carbon. That's what started the whole thing when I was at Harvard. This was precisely what I had to look for, an alternative, cleaner, more efficient and cleaner way to use fossil energy. And the Russian chemists have calculated that the energy in carbon combustion is about 20 or 25 times the electric energy. This gives you an idea why I cannot sleep when I build the reactor. No, because now we have reached 10, but we have as a potential 20. With 20 times the electric energy, we will never reach 20, but certainly 15 is
absolutely.
And in essence, but also another point to clarify, the combustion of carbon is, first of all, it's cleaner than conventional combustion. Why? Because the gas bubbles through the liquid, and the liquid itself traps all the gunk, all the hydrocarbon, and then the arc will destroy them. So it's dramatically cleaner than carbon combustion. There are no fumes coming out of the reactor. It's only clean MagneGas. So the environmental qualities and the scum cannot be discussed. But it is also more efficient. And that's why we have this very high efficiency. Because in carbon combustion that you have now and in everywhere, in Romania, Israel, Italy, basically you only produce CO, synthesized CO, that's 288 kilocalories per mole. Very energetic, yes, but it's only one. In the plasma, as Professor Mandela correctly indicated, the plasma surrounding the arc, we also synthesize H2. H2 is 110 kilocalories per mole. And we have all sorts of secondary reactions. They are very isoenergetic. Very isoenergetic. So that is why we have constructed and developed not only chemistry, they don't even think of approaching this thing with quantum chemistry. Quantum chemistry predicts that if you have an arc in water, in distilled water, what you produce syngas, which is 2/3 hydrogen, 1/3 CO. Now, so assume that this is correct. We have an idea how 20th century theory are off. I have an idea why I really mentioned that the Texan with the cigarette may sue me. So let's assume that this is correct. So we have about 33% CO. Very well. Now CO is combustible, and what it does, CO turns into CO2. So therefore, if quantum chemistry had been correct, then the exhaust of MagneGas should have 40% CO2 in the exhaust. 40% CO2 in the exhaust. I will not be here, I will not even have an environmentalist. Instead, we have 3%. So we're talking 3 to 4%. We're talking about a factor of 10. Quantum chemistry is off, or a factor of 10. which means beyond none of those manipulations of the 20th century, you throw a function and parameter, you adapt theory to the theory that you below, you know. No, it's just too big. Similarly, they have up to 14, 15, 16% oxygen in the exhaust. Where is this oxygen coming from? If it is made of H2 and CO, where is the CO is triple bond, so there is no, where is the oxygen coming from? And on and on and on and on. So, so you are welcome to work on studying so measure that on one clear condition, that in the moment you think of 20th century theory, I'm sorry, I cannot collaborate with you, I cannot waste my time. So I have to be very, you have to approach the new, more adequate, not final theory, but at least more adequate than the 20th century. Under that condition, you are welcome, all of you, no exception, you are very welcome, my appreciation.
He's stating that because there are many anomalies by conventional physics, so we urge all scientists and physicists who want to investigate and explain all these anomalies. We welcome them, but you have to have an open mind, and you have to throw out all your preconceived notions of 20th century physics and chemistry, and study very thoroughly the work of Professor Santilli and his many colleagues who have verified in the tests, and we will get much further that way.
Not only that, bring more the energy and turn more waste into energy. Okay, Dr. Animoli has one question.
Yes.
To contact with Dr. Santilli about 1 year ago. The major barrier, ordinary layman people like me, to in everywhere, even it's unlimited application. So that will also suck you into something very deep into something. So that's the two things that I have been experiencing. So okay, let's. Thank you for your presentation.
I'd like to ask also Alan.
Alan,
Yes, Alan.
Okay.
Thank you for inviting me. It's an honor.
Lucas is my brother.
Fire and water.
To fire and water.
שזה ה-H12, אז לאן הולך הגוף? היא מתפרקת?
Thank you.